Hi guys, welcome to CodeWide, and again I'm back with another question. It's a maximize distance to the closest person problem. It's a LeetCode question and it's a medium level question. So before I start the explanation, I just want you to read the question. I hope you are read the question. So what they're asking is they're given the array representing the rows of seats where seats of I is equal to 1 represents a person is sitting in the ith seat, I0 I equal to seat of I equal to 0 represent the seat is empty. So there will be at least one seat empty or at least one person sitting, right? And they have given find the distance between the closest person to a person called Alex to be maximum. Return the maximum distance to the closest person. What do I mean is, let's look at the example. So in this, the maximum distance is 2 because if Alex sits here, the distance between him and the other person will be maximum, that is 2. If he's sitting here, the maximum distance will be 1, right? So we have to make sure that we have to make Alex in such a position that the distance between him and the other person should be maximum, right? So that's what it says, that Alex sits in the second open seat, that is here, seat is seat of 2, then the closest person has a distance of 2, right? So the question if Alex is sitting in any other seat, the closest person distance will be 1. So we are making him sit here, so the distance will be more, right? So in this case, where do just think where will Alex sit? Obviously at the end, right? If your Alex is sitting at the end, the distance between the person and this guy will be 3. So yeah. So how will we solve this? Basically, there is a lot of different approaches, and we are going to solve this by somewhat easy and interesting approach. That is using left and right count. I hope you might have heard about this approach. For example, let's take first example itself. There is one. Let's take 1 0 0 0 1 0 1. So what do I mean by left and right count? So wherever you find 1, you count it as, you take a 2 arrays or vectors named as left and right. Why are we taking this? You will get very quickly. So wherever you find 1, you put 0 because it's already full, right? You don't, I mean, you can't make Alex sit here, right? So distance will be 0 and you can't make him sit here also. If you're making Alex sit here, so maximum distance will be 1, right? So we'll say 1. After 1, if there is empty seats, then you start counting as 1, and this will be 2, this will be 3, right? And again there is 1, again you will say 0 because you can't make Alex sit here. So again count starts 1 and this will become 0 again. So for right array, you count from here. You just do the same thing for even for right, but you start from the right end, right? So if it is 1, as you know, you count it as 0. For 1, you count it as 1. Sorry, for 0, you count it as increase the count 1. Again, you found 1, so 0. Again, 1, 2, 3, and again 0. So this will be the vector. So now what do you do is you just find the minimum of 2 variables. That is, you find the minimum of these variables, but there is a condition in this. Wherever you find any of the number as zero, like if any of left or right will be zero, you have to take the maximum. I'll say you why we have to take that, because I'll just show you the next example. In that you'll be clear why we are taking the maximum. For this, I mean, you don't need. I mean, in this example, we can't say that why we are taking maximum clearly. So, as I said, just keep in mind when there is any of these zero, any one of this zero, we have to take the maximum of both the values, or else we have to take the minimum of these values, right? So this will be zero. So what is the minimum? We'll get one. What is the maximum? Zero. What will be the minimum? One. What is the maximum? Sorry, what is the minimum? We will get two. What is the minimum? We'll get one. What is the maximum? We'll get zero. So we, in this, after getting this resultant, you find the maximum. Uh, the thing which is in maximum is your answer. That's it. Because in the maximum distance is two, as you saw. This is the answer. That's it. Now let me take the second example so that it will be clear for you why we are taking maximum when there is zero, right? Uh, Sorry. Uh, okay. So now let's take what was the last example. Second example was 1, 0, 0, 0, right? So now if you take left and right array, what will be the value? There is 0. When as I said, wherever you find 1, put it as 0. After 1 the count starts, that is 1, 2 and 3. For right there is no 1, right? You don't know how to, like, if there is no 1. If there was 1 at the starting, you can put, or you can start counting the numbers, like there is 1 here but there is no 1 at the end. So if there is no 1, just put 0, because there is no any person right nearby. So just keep it 0. Put it 0, in 0 and 0. I hope you are getting why we put 0, because see, here you have a person here. From here, so you are counting from here, right? There is empty seats to a person, near to a person, but there is no nearby person here, right, to a right side. So since there is no person nearby, you are just putting 0, right? So in this case, actually the answer is 3, right? If you are making the person sit here, then there will be a maximum distance. So if you are taking a minimum of this, we get 0, right? And if you are taking a resultant, you will probably get a resultant as 0, but we don't, our answer is not 0, right? Our answer is 3. So in this case we have to take maximum if there is any sort of 0 included. So if there is any 0 in left or right array, we take the maximum of two numbers, so it will be 3, 2, 1 and 0. So in this resultant, what's the maximum? That is 3. I hope you got the approach now. So yeah, let's start coding. Let's take it as for our simplicity, we actually basically need two vectors. That is L and R, and we also need a count. And what else do we need? We need a boolean f true. Let's keep it false at the beginning. You will I mean, you'll come to know why we are taking boolean variable, because as I said, if there is one only, you start counting, right? From if there is one and then there is zero, you start counting. If there is no one at the beginning, then it's I mean, you don't count. So we are taking for that use. You we will probably get to know while I count. So let's take first for the left array, that is the start size, and we say that if s of I double equal to 1. If this is the case, we say that f equal to true, because yeah, there's a person. So f equal to true, and we say count equal to 0. Like as we discussed, if there's a person, we just count it as a 0. Or else what we do is we say C++, because we start counting. And also we say that if there is if there is no one, if there is no if there is no one, then what to do? Then just say c equal to 0. There is no person, so count will be 0. Then we just allot it to a left array. That's it. I hope you got what's the value of f here. F is just what it represent if there is a person before it or not, right? Cool. We will do the same thing for right, but we'll just say f is false here, and we'll also decrease this s dot size of, and s is greater than or equal to 0, and I minus and f equal to 0, else plus plus, and this will be r, right? And the final array will be like for int equal to 0, I less than s dot size of I plus plus, and we take a resultant here. We'll take answer equal to 0, and we'll say that answer equal to max of answer and minimum of what did we discuss, that is L of I and R of I, right? And we'll also say that if in case L of I is double equal to 0 or R of I is double equal to 0, what we do is we just say answer equal to answer of answer max of L of I and R of I, right? That's it. And we just return this, right? Return answer. So yeah, it's working. Basically, I did not mention the size, so there was sort of an error. Now let's submit this. So yeah, it's working. Yeah, if you like the content, if you like the solution, do like the video, and do subscribe to the channel for more updates from this channel. Yes, thank you. Keep coding.